In the last video, we talked about relations, domain, range, and function, and this video is going to focus on function notation and evaluation. So kind of the next stepping block off of where we ended. And so if you're not quite familiar with what a function is, I would strongly recommend spend some time with the definition and the examples presented in the last video. But once we verify that something is a relation, there's tools that accompany a function that we need to be familiar with. Domain and range is one, but then the language that we see is actually super critical. When we see something like y is a function of x, really what that means is that we can say y is equal to f of x, meaning, and here I have it written form, if we want to obtain the y value, right, that's our goal, we need to do something with x to get that y value. And then the formula that's on the other side, that is this f of x, tells us the formula that, or the recipe, if you will, that we need to follow in order to get the y value using x. And also, when we use this language, y is completely isolated. So it appears as like y is equal to x squared plus 3x plus 5. I don't know. So this part right here, that would be your f of x, your formula, your recipe to get y. Okay? So when we use this language too, it also implies that x is what we call the independent variable and thus represents the domain of our function, while y is the dependent variable, and then that represents the range, or the y values that we obtain are the range. Okay? So kind of new hat, kind of old hat with this stuff. But now, more importantly, is that when we are given this y is equal to f of x notation, we're actually able to evaluate the function. Or if we have a particular x value, a particular value of the independent variable, we can get the corresponding y value, the corresponding range value. So here I have a couple examples. I'm going to do one with you, and then I'm going to pause the video and have you do it yourself for the second one. So first we want to write each equation as a function of x, so that means again we want y is equal to f of x to appear. And then when we're at this point, we want to determine the function value at x is equal to minus 2. So to get to this point, y is equal to f of x, we need to isolate y. So we need to solve for y, and this isn't too bad. We've been used to doing this for quite a while. So subtract 4, so I get 5x minus 6 is equal to 2y, and then divide by 2, so y is equal to 5x minus 6 over 2, and please do not say that this is 5x minus 3, right? If you want to say something, you can say it is equal to 5 over 2 x minus 3. So again, you'd have to divide both the 5 and the 6 by 2. So divide each of the terms by the denominator. Okay? But I digress. This first form isn't actually all that useful, but what I can say is then that really instead of y, I can write f of x is equal to 5x minus 6 over 2. Okay? So again, y and f of x are used interchangeably per this notation. Okay, and then so I completed the first part. Great. Now it says determine the function value at x is equal to minus 2. So really what that means is that instead of having x in my function, I'm going to write negative 2 for every occurrence of x. So if I look back here, let's go back. Okay, I am going to have 5, and then I'm just kind of following this formula, so 5, and then I hit an x, so instead of x, I'm going to substitute in minus 2, and then minus 6, finish it off, and then minus 2. So then, if I evaluate this, this is minus 16 over 2, which is minus 8. So I would say f of minus 2 is equal to minus 8. Okay? So big idea here is if I'm substituting something in instead of x, I replace all occurrences of x with minus 2. Okay, so for the second one, I want you to pause the video here and try it out. Okay, and then resume the video when you're ready to see the solution. Here's the solution that I obtained. So in terms of a function, I got that part right here. So again, isolate y, and then instead of writing y, we write f of x. Okay, they mean the same thing. And again, just remember that this is a formula to get y based on x. That's really what this means. Okay, and then for the second part, f of minus 2, please, 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 please do exactly what I did. The main thing that students forget is the parentheses. If you forget the parentheses, you're gonna get a completely different answer, right? You're gonna have probably minus 8 and then minus 5, so you'd have minus 13. You're off by a lot. So just make sure to whenever you're substituting, that you're substituting in using parentheses. Okay, so I got 3 for the output there. All right, so that is all fine and well. Now we're going to move on to something that's a little bit more challenging. Something that you will see in both pre-calculus and in calculus is called the difference quotient. Okay, so this is called the difference quotient, and this is super critical to your foundation in calculus for sure, and well, pre-calc for that matter too. So there's a lot going on here, and students, try and do this all at once. And I'm going to say, if you feel confident that you can do it all at once, hey, great, do it. But I find it's best to do this in pieces. So what I'm going to do is look at this piece first, this piece second, and then do the whole numerator third, and then finally introduce the denominator of h at the end. Okay, so let's look at f of a plus h. Okay, if I do this, what this means is that for every occurrence of x, okay, so again, this was x, I'm replacing that x with a plus h. So in my function, instead of having x squared, I'm going to have a plus h squared. Okay, and then plus 2, and then I have another x, so I am going to have a plus h. And it is going to be most beneficial to us if we do the FOILing and combine like terms. What this ends up being is a squared plus 2ah plus h squared, and then for the second part, plus 2a plus 2h. Okay, a little bit of writing, yes, but we can deal with it. Okay, so that's the first part. Second part, f of a, is just going to be, instead of every occurrence of x, we replace it with a. So it's going to be a squared plus, minus, rather. And I should actually have that. I need to fix this. Too bad none of you were here to correct me. Okay, there we go. Minus 2a in parentheses. So this is really just a squared minus 2a. All right. Now I'm going to do the subtraction. So I'm going to do f of a plus h minus f of a. And if it helps you, I always do brackets at the beginning so I can see what I'm substituting in. So this is going to be a plus h, or f of a plus h, that I found above, minus 2a minus 2h. Okay, and then I'm going to subtract the f of a, which was a squared minus 2a. Okay, and now there's no further simplification I can do with the parentheses in the first part, so I'm just going to drop them. A squared plus 2ah plus h squared minus 2a minus 2h. And then for the second one, remember, this is really saying plus a negative 1 times all of this, so I would have to distribute, and I'd have minus a squared plus 2a. Okay, and now I can combine like terms. The a squares are going to end up reducing, as are the 2a's, and I'm left with 2ah plus h squared minus 2h. Hey, that's kind of nice. Okay, and now what I'm going to do is do the last piece of the puzzle here. F of a plus h minus f of a all over h. So this is saying to me that I need to take the numerator, which I found to reduce to 2ah plus 2h minus 2ah plus h squared minus 2h, and divide that by h. And what this really means is that I take each term and divide it by h independently. Okay, h squared over h minus 2h over h, and this ends up reducing to 2a, those would reduce, h squared and h would reduce, so plus h, and then these would reduce to minus 2. And this would be my answer to this entire question. Okay, so a lot of work to do, but I recommend breaking it into pieces. Okay, so just to check for understanding here, I'm going to give you a quiz question, where you have to do a little bit of function evaluation.